All right. I'm going to turn this down just a bit on my end. There we go. I don't know if we got anybody in chat yet, but hello if we do. Let me go ahead and transition over here. Hello. All right. That to me looks like I have something on the side of my camera over here. Cool. I hope everybody's doing fantastic if we do have anybody in the chat. So, I've been doing a bunch of research since I ended my stream yesterday. And the reason being is this. So, real quick, let me open this up. This is my test from yesterday. When after I finished my stream, I packaged everything, I uploaded it to App Lab, I gave it all a test. This is that test. This fourth number up here is the FPS. And this is just looking in the general direction. Not even seeing the generator, just looking at its general direction. We're getting 11 FPS. Very unpleasant. Actually, I might have said 17. It's a very poor video quality, so sorry about that. Yeah, I accidentally broke the inventory system because I made a mistake. But you can see we're getting maybe 10 to 15 FPS here, okay? That is just looking in its general direction. Now, I did also teleport into it, and it looked like it might have gotten a little bit better. Not by much, but at least a little bit, to a point where it seemed a bit more playable. And so this morning, I did a quick test before I started making any drastic changes or anything. I did this test where I took out the corridor and I took out the walls. This is not being read. I can't read that very easily. It was roughly 30 FPS here. Okay. So about double of what I was getting before. Now, still not great, but a lot better than what I was getting before. I also haven't yet done any distance culling or anything like that. So that will probably end up having some benefit. I had forgotten that I disabled the portal when I took everything out. So yeah, roughly 30 FPS. Still not great, but at the very least, it's a lot less noticeable that there is an FPS drop in the Quest 2 headset. I don't know what's going on back here. I don't remember seeing that in the headset. Maybe it was. Maybe I just wasn't paying attention. But anyways, so as you can see, FPS is absolutely terrible on the Quest 2. So I did a little bit more research into a number of things. By the way, I wanted to give a thanks to this guy. By the way, I was looking at his implementation of procedurally generated 3D dungeons. I don't know that I'll do 3D, but he did give me a lot of good ideas. I'll get into that in a second. Thank you, Chimpy. Appreciate it. So anyways, so I did some research last night on instant static meshes. Now I don't know how true this is, okay? Because the only forums I was able to find, the most recent one looked like it was from 2021 or 2022. Most of them look like they might have been from like 2015, so like older forums. And a couple of them seem to imply that instant static meshes do not work on mobile devices, or at least not all mobile devices. I was not able to find any guides or any lists as to what makes it work and what doesn't make it work. So I'm not really sure if that is still the case or not. I wasn't able to find anything from like this year at least. So I don't know if that's even still an issue. But given that taking out all of the instant static mesh stuff and just leaving myself with the floor and ceiling doubled my FPS, I feel like there might be something there. So I've spent like all of last night. I've spent a long time now looking into and trying to find ways I can simplify the dungeon generation even further to make this better. So with that, long-winded intro. I bring to your attention this wonderful video by Vazgriz here. I won't play through the whole thing. It's like a 9-minute video if you guys want to see it. This is built in Unity too, so I can't even follow this as a tutorial, and it's more of a guide. I don't think he shows a bunch of code or anything like that, but he does walk through his process. Now, I was planning on doing something similar to what he was describing here eventually, but I was also trying to keep it very simple, and so now I think I have no choice but to go into the complicated nitty-gritty stuff. So essentially, to break down what he's got here, is he breaks down dungeon generation into a couple steps, okay? So first off, we spawn the rooms. We already have that handled, okay? That's not a problem. Second, just spawn them anywhere in the environment. Second, once you have this down, you do two things. You first create a Delani triangulation, and then using the triangulation between all of the different rooms, you then create a minimum spanning tree to make sure you have a single path from any one room to any other given room. So essentially that's what this green path is here. So if you look, every single room is connected in some way to the original minimum spanning tree. Then you take just a random selection of these other black lines, which are just other parts of the Delani triangulation, and you just select a bunch at random, and these just become extra pathways between different rooms in order to add a little bit more uniqueness into the generation. I have not done this before. I have heard of this before. I have not actually done this before. So, we're going to be trying this today. The general idea is pretty simple. I have this pulled up in a couple of other tabs. This one's the minimum spanning tree one. So we're going to be trying to break this down as easily as possible. So, one of the things that I pulled up is just the general idea of what Delani triangulation is. And the other thing is there's multiple algorithms to get this Delani triangulation, but essentially the point is that you have the shortest possible path between every single point in an area. It's more for 2D areas, but I'm sure you could easily modify this for 3D. I think he talks briefly about how to modify this for 3D as well. So that's essentially the idea here. We're only focused on 2D right now, so we're only going to focus on 2D right now. Now, there's multiple algorithms to do this. He had mentioned the Boyer-Watson algorithm. So we'll have a quick look at this. I did bring up a couple of guides on how to do something like this. So we'll start with this, and then we'll move on to the minimum spanning tree once we have the Delani triangulation down. And the hope is that by having all these corridors between the rooms, we can have shorter corridors, which will remove our tiles. I'm not going to worry about walls right now because my idea for the walls is walls for corridors will probably still remain the same. It's still going to be a tiling system. Walls for the rooms, however, I want to change. Rather than being 1x1 grid, or rather than having it be a part of like the 1x1 grid, what I'm going to do is I'm going to have several different variations of the rooms. So this is going to be a two-step process, okay? So we're going to take our rooms, we're going to generate the rooms, we'll create the Delani triangulation, and then determine the path that all of these rooms are going to connect to. Okay, for now, we're just going to focus on getting these rooms connected. I'm not going to focus on the walls or anything right now. Once we get to the walls, which probably won't be in this live stream, I'll probably have to do another one for this. Once we've gotten this part down, what I'm going to do is we're going to have a preset of walls. So we'll have some that have a door somewhere along the left side. We'll have some that have doors somewhere along the right side. Doors in the center, doors in two different spots, all these different things. And the reason we're going to do it this way is in order to determine how many doors or whether we even need a door on any given wall, we first need to know what path we need to generate. And then before I even get the walls in, I'm also going to do another performance test because I want to make sure that this is actually going to work well. If this doesn't work, we're going to go on to plan B, which is going to be a total overhaul of the dungeon generator yet again, going on to version 6. At this point, I'm going to reach double digits in no time. Where we're basically just going to have tiled rooms and tiled corridors. So, or maybe we'll even take out corridors altogether. I don't know. But basically, we'll have everything as a preset. We'll have preset determined corridors. So we'll have some that are just straightaways. We'll have some that kind of go at an L angle. We'll have some that go at a T angle when that's necessary. All these different things. And then we'll have rooms that are predetermined as well. So that's kind of the intention of what it is that I'm going to be going for here. Because to be completely honest, I'd rather not have to overhaul the entire dungeon generator yet again. I'd prefer to just have to do some of this. Okay. So with that all in mind, let's get to work on some of the dungeon generator. By the way, I don't know if I said it. Thank you very much, Chimpy3D, for the donation. And thank you for the good work. I think I said thank you, but just to make sure I'm hitting it correctly. Because I know I had a very long-winded intro here that I was trying to get through. Okay, perfect. All that out of the way, let's get to work on this dungeon area. So mostly what we need to worry about is the corridor, because the corridor, by this point, we have all of our rooms generated. So I think I'm going to do all the triangulation. All that's going to happen in the corridor itself. Okay, I'm gonna disconnect everything right now. Okay, yeah, we'll disconnect everything. Okay, because we need to do a bunch of stuff before we even get to this point. So, yeah. And actually, I might need to change the way the starting point gets generated as well. So this is going to be really interesting. All right. So, let's do this. Let's start with the Delani triangulation. So I did a little bit of research into this. So my general understanding, I like this picture because it kind of gives me just a general idea of how it looks like this is supposed to work. I haven't even read through the pseudocode yet, but the way it looks like it's supposed to work is you create one giant circle around the entire... Thank you for that, Unreal. We create one giant triangle around all the current points. Then, using this triangle, we create a bunch of smaller triangles within that original larger triangle until every single point has a connection to one triangle or another. So this one shows with just 3 points. So you start out by getting just one single point. In this case, it's point 1. You're supposed to go from point to point, so you're supposed to number them. And then so you take point 1. This one, you can kind of see it's got just a circle. So from what I understand, you're supposed to draw a circle around. It looks like it must be the nearest 2 points. Or maybe it's just every single triangle that's in existence. And then you find whichever triangle has that point, or whichever circle has that point. And then using that point, you then create a triangle that basically connects everything. That's kind of my understanding. Yeah, this is a bit of a confusing way to do it. Because I could kind of see, it looks like it kind of takes over. Okay, let's look at the pseudocode real quick. Before I get too far ahead of myself, maybe it's better we look at the pseudocode. Okay, so if we take a function that has a parameter of the point list, so the list of every single point, the triangulation is an empty triangle mesh data structure. The set of coordinates defining the points. Add a super triangle to triangulation, which must be large enough to completely contain all the points in the point list. Then we take every single point in the point list, and for each one, add all points one at a time to the triangulation. Okay, so bad triangles. Empty set. For each triangle in triangulation, do first find all the triangles that are no longer valid due to the insertion. Okay, how do we know which ones are valid though? If pointless is inside circumference of triangle, add triangle to bad triangles. Okay. For each triangle and bad triangles, find the boundary of the would that be pronounced polygonal or polygonal? Kind of feel like it should be pronounced polygonal. Polygonal hole. For each edge and triangle, do if edge is not shared by any other triangles and bad triangles, add edge to polygon. Okay, the only part I don't understand is how do we find which triangles are bad triangle? That's the only part I don't understand. I didn't see anything that defined what a bad triangle technically is. The flip algorithm. Oh, wait. This looks like it has a list of just every single algorithm. So let's see. Or maybe just a bunch of them. So if I look up Watson. No. Okay. Okay, let's start this one at a time then. So first off, we need a triangle that's going to cover all of our points. So going back to the weird way of doing things, let's create a function for this. And what we want to do, I'll call this triangulation. Okay, that's what we'll call this. Okay. So for each point here, let's do this. Let's create a local variable, room centers. Okay. And so we have our rooms here. And what I want to do is for each room. Okay. I got an idea for this. Hold on. We take for each room. Okay. This needs to be changed to a map. Hold on. First, I got to change this. Let's do room. Let's do room. Okay. And then we need a map. The second point is going to be a vector. So my... Actually, this might need to be swapped around. Let me swap this around. Vector, room. Because that might be important for later. I can see where that might be. So for each one, we get our room centers. So for our rooms themselves, hold on. Come here. So for our rooms themselves, one of the things that I found really early on, which was really nice, is we can actually take our floor static mesh and we can get the origin point. This prints out the location in the center point. So for each one, what I'm going to do, get floor static mesh. Wrong thing. Get floor static mesh. Okay. So there's that one. And then for each of our room centers, we're going to add in a new point here. Okay. So our array element's going to go into here as our, I think that's a value, if I recall. I believe it's key and then value, if I recall. And then from this, get component. Was it get component bounds? I think it was good. Yeah, here we go. Perfect. Get component bounds, and there we go. Okay, so that's going to give us... This has to be the first thing that happens. Okay, so this is going to give us all of our points, and it's also going to allow for us to bind them each to rooms. So that way, when we go to finally start connecting all the corridors together, we easily know which room we're attaching to, because we're not going to go like straight to the center of each room. We want to find a border point, or hopefully in an eventual case, we're going to want to find a door that we're going to be connecting to. So let's see here. Bam, there we go. All right, and then let's see here. So once we found this, we need basically a triangle that that covers everything. So let's see. Create triangle that... Should I just be making like a large triangle maybe? Holds all points. Here we go. Triangle / circle enclosing a set of points. For computing the minimal area triangle enclosing a given set of points in Euclidean 2D space is described in the following open access scientific note. Okay. Smallest circle. Is there maybe a smallest triangle? Hold on. Smallest triangle algorithm. Because if there's a smallest circle, maybe there's a smallest triangle as well. Finding the tightest smallest triangle. That, oh, perfect. This might be it. Let's see here. Hold on. Wait, is this the solution to the answer? Hold on. I'm supposed to... that given a bunch of points on the Euclidean plane, I have to return the tightest, smallest origin centered upright equilateral triangle that fits all the given points inside of it. Need to go over all the possible points and finding the point with the largest Euclidean distance from the origin. I mean, the other thing we could do, right, is we could just keep growing a triangle until we eventually find it. I might just take the easy way for now, because I know none of my rooms are turning out really big. I might just create just a very large triangle that's unlikely to miss any points. Yeah, let's just do that for now. We're going to keep this real simple. I don't think the size matters, so we're going to keep this nice and simple, okay? Okay, so let's take our triangle. Okay, this is going to be a vector. Actually, do I need to create a struct for this? Hold on. Because I'm trying to think, right? We're supposed to have a bunch of triangles. I think I might need a struct for this. Just so I can define all 3 points in a triangle. If it was just 2, I wouldn't be as worried about it. Yeah, I think we're going to need to. Okay, let's do this then. Hold on. Let's create a blueprint structure triangle. Let me just go and set this real quick. Ooh. Triangle. That's not right. There we go. Okay, perfect. So if we take our triangle, it should have 3 points. Point A. Point, ooh, that's weird. Point B. And point C. Okay. And each of these needs to be a vector. Perfect. All right, so with this, let's just create like a really massive triangle. Make I don't even know if I'm doing this completely correctly, to be entirely honest, but I'm gonna hope. Actually, let's do it this way, because I need to see this. Draw, debug, line. Because really at the moment, I just need to make sure that this is actually going to work the way I want it to. C, and then these two. Perfect. Okay, so this is going to be the master triangle. Okay, so we'll do duration of 20 and a thickness of 20. Okay, so let's just give this like a rough size. I don't know if that's going to work or not, but let's see. Let's see what comes out just by doing this. Oh, wait, hold on. I didn't add that back into the dungeon generator. I forgot I still have the corridor generator disabled. This one comes here. Good. And then this one, I'm going to have this skip everything. We'll just generate the ceiling. I'm not exactly seeing anything. Hold on. Let me make sure we're actually generating it. String. Should start. Okay, it's not doing anything. Hold on. Am I still skipping over it? Let me check here real quick. Oh, that's why. I'm never even calling it. That would help if I was actually calling the function I just made. Simulate. Okay, there we go. Okay, too small. I'm in the complete wrong actor. There we go. Okay, let's try this. Let's try just adding a 0 onto the end. This should be more than big enough. Oh, there it is. Oh, why is it all the way over there? Oh, wait, hold on. Does it? Do I maybe not need this part? Because come to think of it, we're supposed to be at the center point. Let's see. No, it's still generating over there. Okay. Oh, wait. I think I know what's happening. Okay. This should fix it. I'm curious if it matters. I've noticed most of them aren't like right triangles like what I'm doing here. I hope that's not a bad thing. Oh, wait. Is this right? 1, 2. I can't even. Hold on. I need to zoom out a bit. Okay. It kind of looked like a square to me for a second. Okay. Hopefully that'll work. Hopefully. I could probably even decrease the size a bit. Just try and make it a little bit easier to see. There we go. That's more manageable. Perfect. Okay, I'm gonna add back in that get actor location too. Actor location should be at 0, 0, 0 anyways. I want to make sure that we're doing everything correctly. Perfect. All right. Okay, so now we have our first triangle. So let's say point A, point B, point C. Perfect. Okay. I'm gonna make debug triangle. I'm gonna make just real quick a function so that way I can see this real quick. Because I'm gonna be using this all over the place right now. Okay, triangle. Okay, and I'm also going to drop in our color here. Because I want different colors for the master, and I want different colors for all the internal triangles there. Okay, break. A, B, B, C, and then A, C. Perfect. Okay. Actually, I could just do it this way too. Instead of doing a whole make and everything. There we go. So that's going to be our master triangle. Perfect. So we can go and add that in. Actually, I'm going to leave that as a make only because it's going to make the other part a lot easier. Okay. Debug triangle. Oh, did I separate that into 3 different ones? I didn't mean to do that. Hold on. There we go. Perfect. Okay, so this is going to be for our master triangle, so we'll be able to see exactly what this one looks like. Perfect. So now we got our master triangle. Just to make sure everything's still working all right. Perfect. All right, so now we need to start connecting all these different rooms. So that's the minimum span tree. So the way that this is supposed to work, so first off, we need to go through each point in our list. Okay, so that's going to be the first step, which is pretty easy to do. Okay, so going off of our pseudocode here, we want to go through our local variables. Here we go, room centers, not get, keys, perfect. Okay. And we need to go through a for each loop for every single one. Okay. So now we have all of our different points. All right. Now, I still need to figure out what the bad triangles are. So let's see. Boyer, Watson, bad triangles. How do we determine which triangles are bad and which ones are good? Let's also go back and look at this real quick. Hold on, because I didn't read. I didn't read through all this like I probably should have. We could technically make this triangle infinite in size to make sure that all triangulation vertices are contained within it. However, pragmatically, we can make it just big enough to contain all the points. We could technically make infinite in size to make sure all okay. So yeah, they would prefer that you make it just big enough to contain everything. I'm not going to bother with that in this moment, but having created this super triangle and placed our points, we can begin constructing the triangulation. We will now iteratively go over each point that we have passed to the procedure to construct a valid triangulation. In the previous post, we have discussed what makes a valid Delaunay triangulation. A Delaunay triangulation for a given set P of discrete points in a general position is a triangulation DTP such that no point in P is inside the circumcircle of any triangle in DTP. Wait. Thus, the next step is checking if any of our points fall within the circumcircle of any of the already existing triangles. Initially, this is simple since we only have one triangle, the super triangle, which certainly contains all of the points within the circumcircle. We can mark this super triangle as invalid and add it to an array that contains all of these invalid triangles. Again, we're still at the very beginning, hence the array will only contain the super triangle for now. Oh, so there's Okay, so contain the original triangle. Okay. Next, we need to replace the invalid triangles by a different set of triangles that is valid. We can do this by connecting the edges of the super triangle to the initial point that we're currently iterating over. In this manner, we can make sure that the point will be on the Okay, so I wonder if the bad triangles it's referring to are the old triangles. So they're basically keeping the old triangles. Later on, this becomes trickier because we need to determine boundaries of the polygonal hole that is formed in the triangulation, where we, in most cases, marked several triangles as invalid. We essentially need to fill the empty spot where we figuratively deleted the bad triangles by connecting the edges. Okay, yeah. All right, so what they're doing is just storing it in a separate array, is what it sounds like. Okay, that's not so bad then. So, add variable. Triangle. Okay, is there a reason we need to keep it in an array though? Like, is there any reason for us to keep it? Or should we just be destroying the original? Unless it's that they have to keep it for the new triangulation part. Until we've ultimately achieved a valid line triangle. In the final step, we will need to remove all triangles that share an edge or vertex with the initial super triangle, since they weren't actually part of the initial set of points. Okay, so we do need to keep... So let's do this then. We'll keep a bad triangles array. We'll keep it an array just in case. I don't think we really need that. I think we could honestly just remove it. But just in case. And then what we'll also do... Oh! I get it. It makes sense. It makes sense. I see why they keep the array of bad triangles. Okay. I get it. Hold on. Master triangle. Hold on. I understand now. Hold on. Give me 1 sec. Let me... Master triangle. Not get... Hold on. Give me 1 second. I'll explain. Set. Okay, so that's going to be our master triangle. Okay, so I understand now. Okay, so I remember the pseudocode. The pseudocode has us clear the bad triangles sets before we begin any work. So we keep the bad triangles for while we're creating the new triangles in there. So that makes sense. The bad triangles are the triangles that we're going to need to work with to create the new sets of triangles that's going to take its place. And then we need to make sure it gets cleared each time. Gotcha. Okay. So hold on. Get bad triangles. So this needs to be cleared at the beginning of for each loop. Okay. That makes sense. All right. So, and then for each triangulation, so we need to figure out how to make a circumcircle too. I've not made a circumcircle before. So let's see, get triangle for each. I really don't like having for each loops and for each loops, especially because it causes so many like just infinite loop errors. Even though it's not an infinite loop, I hate that Unreal detects it as an infinite loop. They're for each loops. They have predefined ends. There should be no way that a for loop can create an infinite loop. Unless you are somehow like just constantly adding things onto the end of an array for a for each loop. Ridiculous. Okay. Circle. Ooh, Wolfram Alpha. Nice. The circumcircle is a triangle's circumscribed circle, the unique circle that passes through each of the triangle's three vertices. Yep. Where's the formula for it? Hold on. construction for the equation of the circumcircle of the triangle with polygon vertices x, I, y, I for I equals 1, 2, 3 is equals 0. Expanding the hold on. These are a lot of numbers. Hold on. Hold on. Let me check real quick. Does Unreal, because I know Unreal has just a whole bunch of absurd things. Hold on. Circle. Create circle path 2D. Okay, so yes, this does make things a little easier. So I just need to calculate the center, and I need to calculate the radius. All right. That makes things a little bit easier. And I can convert the vectors to a vector 2D, because realistically I don't need the z. Yeah. Okay. So hold on. By discarding the xi column. Hold on. Xi circumradius. Okay, hold on. Let me see if there's a simpler. I'm gonna keep that. Oh, not new window. New tab. Circumscribe circle. Properties and formula. And it's one of those paid things. I understand the reason for these like paid sites, but come on. Is the center of the polygons circumcircle? Actually, I wonder. Oh no. No, that won't work. Never mind. The area of a circumcircle can be found using the same formula. I mean, I know how to find the radius. I really just need to figure out how to find the center point. Because the radius would just be, let's find the furthest point and find the radius to that one. But I just need to figure out... Hold on. Is this giving me area? An example of a circumcircle of a triangle can be seen here. Another formula that is commonly used when working with circles is a circumference. Well, wait, that's circumference. Wait. I know what a is there no... Oh, it's a lesson thing. No wonder. Circumscribe, circumcircle. Here we go. Circumcenter of triangle ABC. Here we go. Let's look into the basic properties of and some relevant examples. We can derive angle-related properties using the properties of angle in a circle. Let's see. 0 is the intersection of perpendicular bisectors of the sides of triangle ABC. Connecting the circumcenter 0 to the vertices of triangle ABC, given three isosceles triangles, 0AB, 0BC, 0CA. Follows extent sign rule where S... Okay. Hold on. The alternate segment. Working examples. See, by definition, a circumcenter is the center of circle in which a triangle is inscribed. This problem let 0 equal AB be the circumcenter of ABC. Taking 1 and 2 gives A equal 1, which... I can't tell if I'm just stupid not understanding this or if I'm missing something. I think I'm missing something. Although I could be stupid too. That thought has crossed my mind. Okay, so here we go. Here is the circumcenter. Where are they getting x0, x1 from? Oh, wait. Okay, so hold on. These are the x and y positions for the circumcenter. Hold on. By discarding... Okay, so hold on. I think those are signs for matrix, if I recall right. Hold on. To matrix transform. X plane, Y plane, Z plane, W plane. Hold on. Hold on. Let me look up something a little simpler. Hold on. Unreal Engine, calculate circle. Is there actually no just like formula built in? I find it really weird given Unreal has like just a whole bunch of absurd formulas that I would never expect them to have. Circle. Hold on. Center, get center of mass, get room centers, get box center size. I don't think that's quite what I want. Hold on. Let's draw circle. Okay, because we will need to do this. Hold on. What if I look up circumcenter? Is that what they were calling it? Circumcenter? Yeah, circumcenter. Okay, here we go. This looks like a, well, relatively more doable. It's the center of a triangle circumcircle. It can be found as the intersection of the perpendicular bisectors. The trilinear coordinates of the circumcenter are cos A, cos B, cos C. and exact trilinear coordinates are therefore arcos A, arcos B, arcos C. Hold on. Circumcenter. Can I maybe find pseudocode for this maybe? Okay, here we go. This will make things a bit easier. Program to find circumcenter of a triangle. Given three non-collinear points in the 2D plane P, Q, and R with their respective x and y coordinates, find the circumcenter of the triangle. Note, circumcenter of a triangle is the center of the circle, formed by the three vertices of a triangle. Note that 3 points can uniquely determine a circle. Examples. P. Okay, so these are the 3 points. So we have 6, 0, 0, 0, and 0, 8. So it looks like a right triangle. Circumcenter of the triangle PQR is 3, 4. Okay, here. I was like, is that all they're gonna give me? Just the input and output? Like, not gonna tell me how to do it? Okay. Refer this post program to find line passing through 2 points. Okay. I don't need that because I already have the line, so I should be good. I think. Let PQ be represented by AX and BY. Okay, so I'm assuming that... Hold on. Does it say what these are? Say PQ and QR. Yeah, it doesn't say what AX and BY are. I'm assuming that those are the coordinate points. 3x minus 2y. Yeah, that's the coordinate points. Okay. I'm curious. I see them defining D here, but I don't understand why. Because it looks like where x is equal to xp and xq divided by 2. Let's see. A line perpendicular to this line is represented as negative bx and a y equals d for some d. Okay, so this is a perpendicular line. Okay. Oh, I see. Okay. However, we are interested in the perpendicular bisector. Oh, I understand. I think I understand. I understand. That makes sense. Okay. I see how they're doing this, how they were doing this in code. So circumcenter is found by taking all 3 sides. You create a perpendicular line that goes straight to it, that goes straight through it. And then wherever those 3 lines meet is what creates the circumcenter. I got it. Okay. So now the question becomes, how do I do that encode. How are they doing it? Hold on. Refer to this program for point of intersection of two lines. Quite frankly, I probably only need to do this for two lines. Because if I know where two lines hit, that's where the third one should hit, right? Hold on, let me check. Because like I said, Unreal's got a bunch of like random stuff in here. Intersection. No. That's for set. Intersection. Check if the ray intersects the sphere defined by the sphere center and sphere radius. Let's do this real quick, because I want to make sure I'm doing this correctly. Let's do this. Okay, hold on. So if we have points A and B, right? I could probably actually figure this out without doing it the way that they did it. I don't know if it's the best way. Hold on. Let me see how they did real quick. Intersection. Let's assume that these 2 points, x1, y1, and x2, y2. Now we find the equation of the line formed by these points. Let the given lines be a1x and b1y is equal to c1. We have now... Oh, we have to now solve these two equations to find the point of intersection. Unreal, come on, you're killing me. To solve, we multiply 1 by b2 and 2 by b1. This gives us a1b2x and b1b2y is equal to c1b2 a2b1x plus b2b1y, which is equal to c2b1. Subtracting these, we get a1b2 minus... this gives us the values of x. Similarly, we can find the value of y. xy given gives us the points of intersection. Note this gives the point of intersection of two lines, but if we are given line segments instead of lines, we also have to recheck that the point so computed actually lies on both the line segments. If the line segment is specified by points x1, y1, and x2, y2, then to check if xy is on the segment, we have to just check that min x1, x2 is less than or equal to x, max... Okay, hold on. Here we go, pseudocode. Determinant a1, b2 minus a2, b1. If determinant equals 0, lines are parallel, else x is equal to c1, b2. Okay, alright, that makes a lot more sense. Let's try to make sense of everything that was going on up here. Okay, this makes a little bit more sense. So let me try something real quick. Hold on, because they're calculating c by doing this, right? So they're getting c1... Yeah, okay, there's C2. Okay, so that should be doable. So first, before I do any of that, I want to make sure I'm getting the lines correct. So let's first get the lines correct. So for the lines, I got a simple way to do this. Distance, vector. Okay. Here's the first one. Here's the second. And here's the third. Okay. Let me also... Actually, let me do this first. We'll do a nice bright green here. Okay, perfect. Duration. 20. Thickness 20. I'll copy this 3 times. Okay. Okay. So to do this, I also need to find look at rotation actually. Find look at rotation. So here's AB. Let me just copy this down a couple times. Here we go. BC. And then AC. We need to make sure that these line up correctly. So that should be all good. Okay. I'm probably going to have to do this in a separate function, but just for some real quick dirty work here. By 2. Okay. Fine. Look. Ooh. Wrong thing. Forward vector. My mind's a little all over the place. There we go. That should be good. Okay. So if we multiply these two together, hold on. Let me do something real quick. Actually, no. Okay, yeah, no, I'm doing this incorrectly. Hold on, add here. And then we multiply this by that. There's our starting location. We need to make sure that whatever start here is the same one we use up here. So this one needs to be A as well. Multiply. Okay, so there's our line starts. Okay. Now the line end. We'll take distance. I'm going to take distance times 2, even though it probably doesn't really need to be multiplied at all. Multiply by 2. But I'd much rather be safe than sorry in case I am wrong. Okay, there we go. So we'll want to use this point as our center point. So I need to space this out a bit more. This is definitely going to need to go in a different function. This is going to get way too messy if I leave this here. Okay. So, and then after we get that point, this is our new center point. So we want to add this. Wait, am I doing this backwards? I am doing this backwards. Hold on. It's supposed to be multiplied then add, huh? I think I'm doing this backwards. Here, hold on. I know a way we can check. Hold on. Oh, why is it not letting me convert that to a vector? Hold on. To vector. There we go. Go there. That can go up there. I don't know why that's still connected. There we go. All right, let's do this real quick. Let's run this real quick. This should go from the center of each side to just the origin of the world, and it did. Perfect. Which actually, incidentally, I think might actually be the circumcenter of this. Okay, so times 2 actually. Oh, no, that's right. It's just going to the center, so they're all meeting at the same place anyways. Okay, perfect. So at least I know we're getting the correct center point there. Okay. Then what we need is multiply by 2. Okay. Yeah. So want to multiply. Actually, hold on, no, because this needs to be a different one. Hold on. Combine rotators. I think this would have to be like another 90 on Z. Yeah, I can't convert that to a vector. That would have been nice, though. Get forward vector. That's going to go in there. And this gets added here to that. And that should be all good. So let's go and grab the rest of this. I hope I have that rotation correct, too. We'll find out here in a second. So let's see. There's 2. Add. Oh, I put that in the wrong one, didn't I? Yes, I did. Line end. Line end. Rotation. Okay, this one looks like it went the correct direction. The other two don't look like they did. Hold on. Let me try something. I'm going to just try to rough this a little bit. Oh, interesting. Okay. Oh, I see what I did wrong. Hold on. Okay, and then one of these is going to be 90. One of these two is going to be 90. One of these is going to be negative 90, I think. Actually, I think oh, perfect. Got it. There we go. So now we got our center point is going to be right there. Should be perfect. So now I need to figure out how to find where all 3 of these intersect. So, real quick, I'm going to copy all this out because this is just a huge mess. Hold on. Let's put this in a new function so that way it'll be a little bit cleaner. Circumcenter. Okay. So that should be fine. I'll save that. Actually, I'm going to make this pure. How many rooms do I want to create? Ideally, I'd like to be able to create as many as I want. At the moment, I'm creating 15, I believe. Let me double check. I think I'd have that here. Yeah, at the moment, I'm creating a desired 15. I don't know if this is going to have to actually be decreased. But, yeah, really my intention at the moment is just to kind of push this as far as I can. Which doesn't, I don't know if that's working the exact way I wanted it to, so. Here we go. Circumcenter. There's that. Okay. And then we need to be able to return. Ooh, not turn. Return. Vector. Center. This actually needs to be a vector. Yeah, to be perfectly honest, I don't know that I'll ever create more than 20 or 25, to be honest. So I guess if you wanted like more of a hard number, I don't think I'm going to be creating more than that, but I also probably shouldn't be saying never because I don't know if I'll end up changing my mind later. So let's say for the time being, no more than 20. Let's see, center. Oh, that was weird. Okay, so now we need to figure this part out. So this. So we need the determinant. And then we also need C1, C2. So wait. Given points A and B corresponding to line AB and point PQ corresponding to line PQ, find the point of intersection of these lines. The points are given in 2D plane with their X and Y coordinates. Okay, so hold on. These are the 2 points. Okay. X1, hold on, X1, Y1, and X2, Y2. And we find the equation of the line formed by these points. Hold on, let me see it. Is there, hold on. Oh, this might actually be perfect. Line seg intersection test. Hold on, will this give me... Wait. No, because then how do I intersect... Calculate closest intersection. Will this give... Hold on. How does this work? Calculate closest intersection. Hold on. Unreal Engine. Calculate closest intersection. Start points, end points. Will this work? I'm going to try this real quick. I don't know if this is going to work or not, but I'm going to try this. Let's see here. Make I actually don't know if this debug is still going to work right now, but we're about to find out. Okay, here's our start. And I'm assuming, if I'm understanding how this is supposed to work correctly, I'm assuming, take that. That's going to give us our point. And then if we come back here to triangulation, draw, debug, sphere. We'll do bright red. I'm going to increase the thickness because we're dealing with a bit of a large scale thing here at the moment. Let's see if this works. It did. Oh, Unreal, I love you. Oh, I love Unreal. Perfect. So that gives us our center point. Yeah. Okay, so now if I take this, my assumption... So we can take this. This is going to give us our center, and the radius... Hold on. I got an idea here. Hold on. Break this triangle. We take this. Find the distance between each. Hold on. Let's see. This one is greater than this one. This will go into a select. So hold on, if this returns true, that means that this one's greater. So we want to return that one, otherwise we'll return that one. We want to check to see if this one's greater than this one. This will go into another select. Okay, so if this one's greater, we want to return that one. Otherwise, we're going to return that one. That should give us our radius. Thickness of 50. I think that'll work. I've never actually used the debug sphere, to be completely honest. Oh. That's not quite what I wanted. Hold on. Let's try this again. Hold on. Do 20. I think I understand what this is. Actually, I'm going to do things a little different. Let's do draw debug sphere. Center, radius, bam. Duration 20, thickness of 60. Slightly less clean way of doing it, but it should still work. And it looks like it did. It looks like it's hitting all the corners. I mean, it's not perfectly rounded here, but I think that's just to do with the segments. Nice. I think that'll work. Nice. All right. Time to call it a day now. No. Okay, let's see how... Now we got to see how we can use this a little bit more. All right. On to the next stage. Where was I? Where was my original... There it is. Okay. Okay. So, we now have our circumcenter. We have our circumradius. Actually, I might just combine that into one. Yeah, let's do this real quick. Or actually, let's do this. Circumradius. And actually, I'm going to put this under one category here. Circle. Circle, compile, save. I'm also going to make this pure. Center. Radius. Float. Here. Oh, I need the triangle too, don't I? There we go. 1, 2, 3, and there's our return. Perfect. Okay, that'll make things a lot easier. Now we don't have to worry about all that. Excellent. Awesome. So, wrong thing. Circumradius. Here we go. Okay, so now we have these two. So now we need to take this a step further. And now we need to figure out... Hold on. Radius. There we go. Now we need to figure out if the current point that we're dealing with is within the radius of this one, or within the area of this one. So, let's see. Circle. Create circle. Yeah, okay, I wasn't expecting Unreal to have anything on that. Okay. Let me close a whole bunch of these before I move on much further. Okay, perfect. All right, let's take this a step further now. Not Unreal Engine. Find if point is in area of circle. How to know if a point is inside a circle. Here we go. Oh, actually, I'm stupid. This is really easy, actually. Hold on. I don't know what... I'm overcomplicating this. Hold on. Again, probably not the right way to do this, but this will still work. Let's just find the distance, and if this distance is less than this one, then it's in. Perfect. That's literally all that I need. Awesome. Okay. So that's literally all that I need to find out. Boyer Watson. Okay, here we go. For each triangle and triangulation, do if point is inside circumcircle of triangle. Wait. If point is inside circumcircle of triangle, add triangle to bad triangles. Wait, would I not want to add it to, like, make it like a potential? Due to the insertion. If point is inside circumcircle of triangle. Hold on. I need to double check this. Hold on. Hold on. I did the circumcircle, right? I am so confused right now. Why would I want to add it to the list of bad triangles if it's a potential... Is it not a potential thing? Second iteration, we will add the next point to the triangular mesh. Depending on its position and the shape of the three triangles we've created, it might fall into 1, 2, or more circles. If it doesn't, we need to mark those triangles as invalid. Hold on. If it does, we need to mark those triangles as invalid. And we now need to find the polygonal hole where we essentially deleted several triangles. Oh. Okay, so we're deleting multiple. Okay, I see. Because we're deleting multiple triangles to create new ones. So if it shows up within the circumcircle, then those are triangles we are now deleting. Gotcha. Okay, that makes sense. Get bad triangles. We're going to add this in. This is going to be one that we're going to add in because it is within the circumcircle. Okay. Hello, DG. How you doing? All right. Then it looks like we need another empty set called polygon. Okay, hold on. What is this for? What does this need to be? For each triangle and bad triangles. Do for each edge in triangle, do if edge is not shared by any other triangles and bad triangles. Add edge to polygon. If edge is not shared by any other triangles. Okay, I see. For each triangle in bad triangles. Transferred money. Emails. Was this a recent email? I have. See, there's an email that just says no reply for, please. This was from an hour ago. VR car configurator. Did I break my emails? I don't see anything by that. Oh, wait, hold on. No, that's not it. I don't see anything with that subject. Hold on. Hold on. Let me, real quick. I'm still here. Let me transition over. Hold on. You're good. I'm trying to remember, or I guess find what email that this is. Hold on. Next. Password. There we go. How are you able to enable performance mapping natively on Quest 2? Hold on, one thing at a time. Let me first worry about DG real quick. I don't VR car configurator. let's see. What about this account? Hold on. Oh, that was weird. To answer your question real quick, so to me, it's just I package it and load it up on the Quest 2, and that's kind of the only idea that I know of, like the only judgment that I have of performance. What did I get disconnected from my internet? My stream's still going, right? Why can I not? Okay, let's do it manually then. So yeah, it's really just, I don't really have any sense of like what my performance looks like. It is possible to plug in a headset and kind of get a rough idea using like debugs and things like that if you really wanted to. I think there might actually be tools as well, but like you can use with Unreal Engine to get a better idea. I'd almost completely forgotten what I was doing. But oh, this is so weird. But to be honest, for me, it's just I'm kind of eyeballing things, and so I check periodically to see, like in between changes, to see just kind of generally what is going on with my project. And so I think I might have just been locked out my password manager. Either that or it just went down. Now it's still up. Why is it not letting me log in? Is VR Playground contact form. Playground contact form. Let me see here. Okay. Well, I have a number by that. Let's see. Dennis. Oh, thank you, Unreal, for getting in my way. Thank you. Hold on. I'm trying to. How long ago was this sent? Is he still there? How long ago was the email sent? Oh, that was weird. Oh, I didn't know I could do that. That's interesting. Thursday, April 6th, 1:17 a.m. That's today? You sent one? Oh no, today's May. I don't know why I thought it was in April. See, that's from 2022. I don't have anything since March, which was about the time I actually shut down my contact form. Actually, it might have been beginning of April. First mail was March 24th. I don't have anything from that day. Here, I'll just real quick, okay? Because I'd rather not be like showing people's. Well, actually, I guess I don't have people's emails on here real quick. Hold on. I can show you real quick. I do not have anything. I don't have anything from March 24th. I shut down actually my original contact form that I was using here in roughly. I want to say it was like end of March, beginning of April, somewhere around there, because I had to change my website a bit. I could show you all my mail right now. Hold on. This is all of my mail right now. It's all been read. I don't have anything currently. Okay, I did get it that time. I'll have a look at this when the stream is over. I'd rather not do this. I'd rather not be like showing your email. Or here, how about this? Let me transition over. Hold on. Okay. Let's see. Yeah, your email is in here. I'm not sharing my screen, right? Okay, good. Other than this. Okay, this might be something I'll have to look at a little bit more. Let me mark this as unread. I will have a look at this when the stream is over later today. All right, there we go. All right, there we go. Let me minimize that. Okay. I don't even remember what I was doing before all this happened. I remember, let me answer Fitter Tom's question. Enable performance mapping natively on Quest 2. Is there, because for me, I really just eyeball it, I guess would be the more accurate way to put it. I don't know if there's like a more proper way to do it. I know there's ways that you can get, like general information from Android devices and stuff like that on the Quest 2, or I guess on Android devices in general. I have not tried using those though. So for me, it's just kind of, I throw it on the headset periodically and do a performance test. I don't know if that answers your question or not, or if maybe you're referring to something else. Let's see here. Oh yeah, I remember what I was doing now. I need to find. Oh no, I found if a point is in the center. Okay, so that's good. Yeah, I don't know if that's quite the answer you're looking for. There are proper ways to do testing and stuff if you plug in a headset. I personally have not tried those methods before, so. Triangle and bad triangles do. Okay, if edge is not shared by any other triangle and bad triangles, add edge to polygon. Okay, I see what they're doing here. So each... Okay, I see what they're doing. So they're just doing lines between each one. Okay. I'm not going to do that. I have the triangles stored as their own structs. So I'm going to have to do this. Hold on. For each edge in triangle, do if edge is not shared by any other triangles in bad triangle, add edge to polygon. For each triangle in bad triangles, remove triangle from triangulation. For each edge in the polygon, do a new triangle. Okay, I think I got a general idea of what I'm going to be doing. Okay. So I'm gonna be changing this around a bit. Hold on. Let's do this. So hold on. By this point, we're all done with the triangles. Yes, I want to go down here. Okay. So let's see. I'm actually gonna copy this and bring this down. For each. Okay, so for each, let me think. So for each one, we're going to want to create 2 triangles because we're taking one and turning it into 2. So yes. So here's what we're going to do. Let's break this. And then what I want to do is I want to get this point here. I'm going to get triangle. Actually, hold on. Let's first remove. Let's do this. So let's first remove this item here. Okay. And then what we want to do get triangle, add triangle, oh no, add, hold on, let me see something real quick. If I go back and look at this, so hold on, we delete these 2, right? So now this one, yeah, it creates 4, so we create 1, 2, 3, 4. Okay, so yes, I am doing this at least mostly correctly. So if we were to look at this, 2, 3, 1, 2, 3. Oh, but we would need to remove one of these sides. So I need to figure out how to determine which side is being removed. Wait. 1, 2, 3. Oh, hold on, because this actually becomes a little bit more complicated. Because I'm also looking at 3 here. 3 here doesn't create 4. It literally just gets added in as a whole new triangle, looks like. Unless there's a different step on the last one. In this manner, we iteratively add vertices to this triangle mesh subdivide. This makes things interesting. Let me see this real quick. I might need to change this. I might not need to do triangles. Maybe I need to have lines between each one. Oh, wait. Hold on. I think I understand. Hold on. Okay. Nope. I got this. I got this. Hold on. Because I wasn't paying attention to this part. So if we look really closely at this, there's another edge here that shares with another triangle. So it leaves that edge there. So what I need to do, that's what it, because I wasn't even thinking about this. If edge is not shared by any other triangles and bad triangles. Yeah, here. Okay. So hold on. Do I need to do this as an extra one? Is this going to get too messy? I think this might get a little too messy. Let's do... I don't want to do this. Triangle. Let me see this. That's the wrong thing. I need a function. No, I don't need a variable. I need a function. Let's see here. Functions. Let's see. Is shared edge. Or how about this? Does edge exist? Let's do this. Okay. Then we want input triangles. So this needs to be an array of triangles. Oh, not text. Vector. This needs to be single. And then this one needs to be point B. Contains edge. And we'll have this be pure. Then using these triangles, we'll want to do... Let's change that to a bool. We want to run this through a for each loop. And then for each of the triangles, break. I don't want to do this. I got it. Hold on. This isn't exactly the cleanest way to do it, but I'm going to do it this way anyways. Hold on. Hold on. We're going to do this. Equals. Let's say not exactly equal. It's true if vector A is not equal. Oh, wait. Hold on. Am I using the wrong thing? Hold on. Equal. Equal exactly, not equal exactly. Oh, wait. I know. I saw it. Hold on. I wanted this third one. Because this one gives me a error tolerance. Okay, so there's B, C. Okay. And then let's also go and copy these. Going to be A, B, and C. So we're going to compare all of these to A, all of these to B. Just say 1. I don't know if that really matters, but... Okay, there we go. So any of these all end up turning out to be true, and any of these end up turning out to be true, branch. Oh, hold on. Forgot to end it. Okay, so if any of these end up coming out to true, we're just going to return true. Otherwise, we're just going to return false. And that's just going to be if we don't come across any. Oh, I thought I crashed it for a second. That would have been really weird. Let's do debug triangulation. So what we want to do is we want to grab our does edge exist. So this is going to take our triangle array. And actually we need to do this a couple times. I hope this does not lag out my computer like crazy when I do this. A, B, B, C, A, C. Okay. And actually, hold on. I'm gonna have to run this through a series of branches, I think. Oh, this is gonna be such a pain right now. Branch. So what I want to do, branch, 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 2, 1. Okay. Yeah. Okay. So this will work. All right. So yeah. Cool. Okay. So here's what we want to do. So if I hope this ends up working right. I can still see an issue with some of these points, but I'm going to have to check. Let's worry about one thing at a time. So let's first worry about this, okay? So I might have to change the way that this works. I'm not even sure yet. Okay, there we go. Make, and make. Perfect. All right. Good. All right. So if this one does not contain an edge, actually, wait, hold on. Let me double check this. For each triangle, remove triangle from triangulation. Hold on. For each triangle in bad triangles, do if edge is not shared by any other triangles. Okay, so yes, if it's not shared. Okay, so we want this to actually be false, I think. I hope I'm doing this correctly. Okay, so this is between A and B, which means that this might actually have to be 2 triangles here. Because we would want to pass in A, C, and then our current point as B, and then we would also want to pass in the current point as A, and then pass in B and C. Yes, okay. I think this is how it's meant to do, or how it's meant to go, I think. So if I take this, so what I want to do is for the 2 points that don't share an edge, I want to take those and basically drop a new point in the middle of them. Okay, I think that's what I want to do. Hopefully I'm understanding this correctly and that I don't have to redo all this. So let's see, this one's going to be B and C. So we're going to have B, A, C, and then this is going to go into C, and then this is also going to go into B. Okay. Oh man, this is about to get really messy. Okay, and then this one, same B. And this is A and C, so we want 1 on A, 1 on C. C. Perfect. Okay, now to test this, I'll do a for each loop here. This is either going to crash my whole computer or this will hopefully work just fine. Debug triangle. If this does crash the whole computer, then I have a possible solution. Let's do bright yellow. Something that can easily be seen. Okay, debug triangle. All right. Fingers crossed I did this correctly. All right, simulate. Oh. I didn't touch the door. Why is the door having issues? Okay, I'm not really sure what was going on there. I do have to fix the door, though. I remember I made some changes to the grab component. Okay. I don't think that worked correctly. Oh, wait. Hold on. Wait. Hold on. Maybe this did work correctly. Hold on. Give me 1 second. Let's try this again. No, that did not work correctly. I'm getting a lot of extra points for some reason. They're all connecting up here to this top one too, which I find is very weird. Check this real quick, hold on. Triangulation, debug triangle. Because we're adding a new one into the triangle. Did I remove it too? I did. Okay. Hold on. Let's see here. Removed. I wonder if maybe I screwed something up here. So we got C, C, B, A. Oh, wait. Hold on. That's not right. Okay, so hold on. There's that. I don't know that that's the whole issue, but that does look like it might have been an issue. Let me do something else too. Let me each triangle. Exist. Let me try something else too. Let's do A, B, B, C, and then A, ooh, C. Okay, let's do a quick make array. It's going to go into triangles, triangles, master triangle. Branch. If this comes back false, then we'll debug it. Otherwise, we're going to take our triangle and we're going to remove... let's say remove item. I don't know if this is going to work correctly, but we're about to find out. Oh. Okay, and... Oh, does it not like these does edge exist stuff? Oh, I was worried about that. Even if I remove this? Okay, that's a little bit better. I still have a whole bunch that aren't even getting connected now. I wonder if I screw up that does edge exist thing. Hold on. Let me check this. It looks all right. Let me try something different. Hold on. Let's do equal exactly. I'm gonna delete all of these real quick. C A If we try this, I might need to change this around. Well, at least we're getting them all connected now. That's something, at least. Oh, wait. Hold on. Wait. Hold on. I got a better idea. Hold on. Generate one. Where in the hell was it? There it is. Split this struct pin. Oh, this is gonna this is gonna be so much worse right now. Best way to optimize a lot of math is to rewrite script in C++. To be fair, it's like very, very small, like very, very slightly faster. But yes, you are definitely correct. I should probably be doing this in C++, but I was just feeling way too lazy. B, C, B, B. Actually, this does need to be false. Okay, there we go. This is the worst way to do it. Oh, man. This feels like the worst spaghetti mess I think I've ever done. And that's saying something. Hold on. What if we... Hold on. I might be able to simplify this down just a bit. Hold on. I might have an idea. I don't know if this is going to work or not, but we're going to try it anyways. Because really what I need to do is just figure out a way to remove points that share the same point with the parent. pin, and remove pin. Perfect. And it's removed them all. Nice. So apparently they're all somehow connecting to the master, which is a problem. So I must be screwing something up over here somewhere. I could try and figure out, man, let me think. I could try redoing this the way that they say it, having just, come here. Because they basically had, like, just edges that they're adding on at, like, a polygon there, right? Maybe I need to have edges and I need to have triangles or something. Maybe I need to change this that way the edges are made out of triangles. Or triangles are made out of edges. I had that backwards. Trying to think real quick what else I could do that's not gonna use VR expansion project. I do not, at least not for this project. I personally like to try and develop things myself, just because to me I like being able to understand. I like being able to understand like what's going on in my project. I like. To me, it just feels like I have a bit more control over, like, just everything. So, why, do they have something for dungeon generation? I don't think the VR expansion project does dungeon generation, does it? Not from what I can recall, at least. Yeah, I have used the VR expansion plugin for a lot of different tutorials, by the way. Yeah, I've done it for sliders. They have a character that works really well. There's a lot of really good stuff in the VR expansion plugin. I don't have anything like bad or negative to say about it. It's honestly an amazing plugin. Okay, I think I might have to redo this slightly differently. Hold on, I have an idea. Oh, I have an idea. I'm gonna have to redo absolutely everything right now. Hold on. Hold on. Let me bring this down. Hold on. Let's do this a little differently. Hold on. Hold on. Let me think here. Yeah. Point A. Ooh. I was thinking of the name. Hold on. Vector. Point A. Let's see. We're going to want another one for point B. Ooh. Okay. Edge connection A. Edge connection B. No. Hold on. No. Am I not able to reference itself? Oh, that causes a problem. Let's try something else. Hold on. God, I don't know that I have anything else I can use. Oh, am I going to have to do this in C++? Oh, I hate that. I might have to do it in C++. Oh, let me try one more thing real quick. Hold on. No, enum is not going to work. At least I don't think it will, right? Yeah. No, it's not going to work. I'm trying to think if there's anything else that I could possibly use. Because I can't reference itself here. Maybe I do need to use a combination of triangles and edges. Why were you asking about the VR expansion plugin, by the way? Just out of curiosity. Let me see this real quick. Hold on. Let me see this. No. I don't think that there's such a thing, but let me see. Triangle. How does this work? Hold on. Make custom mesh triangle. Is this something I made? I don't think I made something like this, right? Custom mesh triangle, geometry script, degenerate triangle. So there's this thing called a triangle list. Make triangle list. Oh, that's from the geometry script. Wait, is this geometry script too? No, it's not. I don't think there's really much I can do with this either. Oh, this is an absolute nightmare. Okay, I think what I need to do, I think I may have an idea. I think what I may have to do is have two things. A list of the triangles and a list of all the edges. Yeah, I think that might work. Because if I have a list of all the edges, I want to try something real quick. I've seen this issue before. I don't think this is what the issue is, but I'm going to try something real quick. I'm going to make this not pure. Make this not pure. Make this not pure. Everything else is already not pure. Okay, this should likely cause a bunch of warnings and stuff. Let's see. I don't think this is what's causing the issue, but just in case. Yeah, it's not. I kind of figured. So here's my thing, right? If I remove... if I do... if I do triangles that are made up of edges... Honestly, I don't know that a lot would change if I'm completely honest. I might be able to simplify down a lot of my spaghetti mess a bit. If I did that. I'm trying to figure out why they're all binding to like the single point at the top. Let me see. Is there any other way to do Delaunay triangulation? Let me see. What other ways are there? For computing Delaunay, rely on fast operations for detecting when a point is within a triangle circumcircle and an efficient data structure for storing triangles and edges. In 2 dimensions, one way to detect if point D lies inside the circumcircle of A, B, C, D to evaluate the determinant. Sort it in a counterclockwise order. This determinant is positive only if D lies inside the circumcircle. Flip algorithms. If a triangle is non-Delaunay, we can flip one of its edges, construct any triangulation of the points, and then flip edges until no triangle is non-Delaunay. Mega n squared edge flips can be generalized to 3 and higher dimensions. Its convergence is not guaranteed in these cases, as it is conditioned to the connectedness of the underlying flip graph. This graph is connected for 2-dimensional sets of points, but may be disconnected in higher dimensions. I mean, this looks like it might be somewhat easier. Computing the Delaunay triangulation is to repeatedly add one vertex at a time, retriangulating the affected parts of the graph. A vertex of V is added. We split in 3 triangle that contains V. Then we apply the flip algorithm, done naively. This will take O of n time. We search through all the triangles to find that one, the one that contains V. We potentially flip away every triangle. Times O of n squared. If we insert vertices in random order, it turns out by a somewhat intricate proof that each insertion will flip on average only O of 1 triangles. So some of these other ones, from what I'm understanding, is rather than taking a large triangle and breaking it down, is to take a smaller triangle and build it up, is what it seems like. A divide and conquer algorithm for triangulations in 2 dimensions was developed by Leon Schatzer and improve. Oh God, these are all names I can't pronounce. In this algorithm, one recursively draws a line to split the vertices into 2 sets. The Delaunay triangulation is computed for each set. And then the 2 sets are merged along the splitting line. Let me see this one. Because I don't think this is the first time I've heard about this flip graph one. Flip graph is a graph whose vertices are combinatorial or geometric objects and whose edges link 2 of these objects when they can be obtained from one another by an elementary operation called a flip. Flip graphs are special cases of geometric graphs. Among noticeable flip graphs, one finds the one skeleton of this might be a lot more difficult than I had thought. Okay, I'm going to try something. This is probably going to be the stupidest idea I've ever done. It might not even work. But I'm going to do this anyways. Let's do this, okay? Okay. Let's do this. All right, let's do a for loop. Okay. Hold on. Nearest. Get nearest vertex index. Okay, hold on. Hold on. Hold on. I still need this section here. Okay. Okay. So here is my idea. It's probably going to be a very, very simplified idea, but oh well. So let's do this. Nearest point. Let's see. Target point. Point array. Ooh. Okay, so this is going to be a vector. Vector array. I'm going to output a vector. For each distance vector. This is, hold on. Did I just move up to my regular variables? The heck? Oh. It already exists. Okay, let's change this. Closest point. I'm gonna say that was kind of weird. Closest point. Let's convert this. Come on. Why is it not letting me convert this to a validated get? Okay, let's do this then. Plan B. Copy. Then point distance vector. It's a terrible idea and I hate this. This is what I'm doing. Okay. Branch. Because really I just need a way to get all of these points close together. Centers. Let's get the keys. Okay. I want to do length -1, of course. Okay. We're going to do a for loop. Okay. And actually, I want to start this at 1. Okay. So here's my idea. Here's what I'm going to do differently. Rather than trying to do like a whole triangulation, minimum spanning tree, all that, I'm going to simplify this down way, way, way more just because I need proof that this works. And what I'm going to do is we'll get our rooms, right? Hold on. Yeah. So we'll get whatever the nearest point is to the previous point. Or, hold on. Oh no, this is going to cause problems. Okay, hold on. I got it. Hold on. I have something going in my head. I'm just trying to figure out how to formulate this into something that'll work. To local variable. Let's see. For each loop. Nearest point. We'll take this as our target point. That is there. Okay. So we're going to try this. Hold on. Draw a debug line between here and there. We'll do bright red. 20 seconds. Thickness of 50. Okay. There's going to be a lot of other stuff that needs to happen in here. But my idea... No, remove this. But my idea is that we can at least get everything attached. And then what I can do is I can just randomize connections between other rooms. And I have an idea for that too. And they're all attaching to each other. Hold on. Let me add in something else. I should have seen that one coming. This isn't working as well as I thought it would. I was really hoping I could find a simpler way to do this. And this does not seem promising either. At this point, I'm really just trying to make something that works. Hold on. Let's see if these are, let's say false. Otherwise, we're going to get copy 1 false. There we go. Okay. Kind of works. Not all of the rooms got connected, though. This did not work as well as I had hoped. Yeah. Okay, maybe I need to change the way I do this a bit. I'm in the wrong one. There we go. Let me try something a little different here. Hold on. No, I don't. I might have to think this through a little bit more. To be honest. Like, I have a general idea. So my general idea was we spawn all the rooms. And then what we do is we go from one room to each one. We go between, we grab every single room, have all of them grab the nearest one, and then attach. But the problem that I'm seeing with that is that the nearest one might not be connected on the node. So it, like on like a main pathway. So we need to figure out a way to do it. God, I'm gonna have to figure out how this line triangulation stuff works. I really am. I'm gonna have to figure out I'm gonna have to figure out how to do this, what I'm doing wrong. Yeah. God, I didn't even get a chance to do the corridors yet. All right. I'm gonna have to end off the stream here for today. I'll definitely have to come back. I'm probably gonna be working on this a little bit on my off time, but I don't know if I'm gonna end up finishing this off on my off time. I might have to finish this off on another stream. But I appreciate you guys for coming. Those of you guys who did. I hope to see you guys back here again if you guys are, or if there is anybody here, I suppose. And yeah. God, Dungeon Generation really is a nightmare. All right. I hope all you guys have a good evening, afternoon, morning, whatever it is, wherever you guys are. And have a good one, guys.